Hello and welcome back. So now in this segment of lesson number 6 about light, let's talk about what different kinds of waves there are. So waves can be broken down into whether they're a mechanical wave or they're an electromagnetic wave or they're a gravitational wave. So a mechanical wave means that the wave is being carried by matter. So the first picture shows an earthquake wave. And we're not really going to get into earthquakes in this course, so that's more for geology. But you should have a general idea that an earthquake is a wave that is moving through the earth. And there are S waves, and then there are P waves, and then there are surface waves. But that's not important. The main thing is the ground is carrying the wave. So as the wave moves, the ground is either moving up and down or sideways or in and out, and then that's what's transporting the wave. The second picture is, what happens if you take a rock and you throw it into a pond. You see the ripples go out. Well, those ripples are a mechanical wave, and they're being carried by the water. And then you also have sound, so that's the third one. So that's a picture of a tuning fork, and then when you hit the tuning fork with a hammer, then the tines, they move in and out like that, and then that causes the air to vibrate, and then the air is transporting the sound waves. So you cannot have a mechanical wave in outer space where there's not enough material to carry the wave. So even in deep outer space, there's still some particles out there. It's not a total vacuum in outer space, but those particles are so very far apart that they can't transmit those waves. So mechanical waves can't be transmitted in outer space. So, for example, I saw a show, and it was called The Expanse, and it was about these people who were moving out into the solar system and colonizing Mars and colonizing the asteroid belt, and how they didn't get along very well with the people from Earth. Well, it got down to the point where there was some military skirmishes, and so they were on a moon that really didn't have much of an atmosphere. So you had these two military soldiers. They were dressed in their spacesuits, and they were trying to communicate with each other. And they didn't want to use their helmets. They didn't want to use their radios because that would have given them away. So what they did was they took their helmets and they touched them, and then that way, when they spoke in one of their helmets, the vibration would be transmitted to the other helmet and then would be turned into a sound wave that the other person would be able to hear. So if they tried to do that without their helmets touching, well, you basically have a vacuum in between the two helmets, and so the sound would not be transmitted. But because they were touching their helmets, the sound was transmitted. So I thought that was an excellent example of mechanical waves. Now let's look at electromagnetic waves. These are light waves. And so there are many different kinds of light waves. So starting on the right-hand side, you've got radio waves. So radio waves are a type of light. Then next to that is infrared. And then when you feel heat being given off by an object, you're feeling infrared light. Then the one that's next to that is the visible spectrum, so you see the rainbow there. Then next to that is ultraviolet light, and then next to that is going to be X-rays, and then next to that is going to be gamma rays. So those are the different kinds of light in the electromagnetic spectrum. Now they can go through outer space. They can go right through a vacuum without any problems whatsoever. And also some of these kinds of light can go through matter without much problem either. So like for example, you know that an X-ray can go through your body and then it hits a plate behind you and then develops into an X-ray. So X-rays and gamma rays are very powerful, and they can tend to go through a lot of matter without interacting with it. Okay, then the third kind of wave that we're going, well, I'm just going to mention it. So not going to really talk about it, gravitational waves. So if you recall, when we were talking about what is gravity, we said that gravity is really a distortion in space and time. So that space and time go together to make space-time, and that normally, if there's no mass present, space and time are flat, and so that means that an object in motion goes in a straight line. But then we said if you put an object on that flat surface, it makes it curve inwards, and then if you try to roll an object, it will follow that curvature. Well, how that gravity is being transmitted is in the form of gravitational waves. Just like if you take a rock and you throw it into a pond, it makes these ripples that goes outwards. So similarly, a mass causes ripples in space-time, and we're going to call those gravitational waves. Now, having said that, that's it. So that's all that I'm really interested in saying about that. So in our next little segment, we want to talk about some other properties of waves. So I'll see you in just a minute.